This is the third experiment in the digital part. So what is the name of the experiment? Is given a 4-variable logic expression. Okay, they will be giving a 4-variable logic expression. Okay, simplify it using the MEV technique. Okay, you have to simplify that expression whatever they are given by using the MEV technique. You know how to simplify it by making use of an MEV technique, isn't it? And realize the expression using the 8x1 box. Just read the question properly. So in the first two experiments, you are supposed to realize the expression by making use of the basic gates. Okay, but here realize the logic expression by making use of the 8x1 box. So they are specifying you to use the 8x1 box in order to realize the expression whatever you have got by making use of the MEV technique. So that's why I have explained what is meant by multiplexer and how the 4x1 and how the 8x1 multiplexer will work. Okay, so this is the IC. Okay, this is the IC. So what is the IC number for it? See, whatever for each and every logic there is a IC. For example, for AND gate there is an IC, and for the NOT gate there is an IC. So likewise, for each and every logic gate there is a one particular IC. So this 8x1 mux IC number is 74151. Okay, and how many pins are there for this? If you just observe 1, 2, 3 till 16. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There are 16 pins. Okay, and the pin configuration is also given here, and in the exam also they will be giving this question, and along with that they will be giving this pin configuration. There is no need to back for you. So third pin under D1, fourth pin under D0, so 12th pin under D7. There is no need to back. Okay, we will be providing this sheet. I will be giving the xerox of it. You can just refer in order to write the diagram. Okay, we will come back to this truth table. So first understand 8x1 mux means how many inputs will be there. As I have already told you in the previous video, 8x1 means 8 inputs will be there and 1 output will be there and 3 select lines will be there. So that's what I have explained in the previous video. So now in this 74151, how many inputs are there? See here, D0, D1, D2, D3, okay, D4, D5, D6, D7. And you shouldn't ask why 12th is considered as D7 and why 13th is considered as D6, because it is fixed. Okay, it has been fabricated like that. Okay, so 8 inputs are there: D0, D1, D2, D3, D4, D5, D6, D7. Totally 8 inputs. Since it is a 8x1 mux, it is a 8x1 mux. 8 inputs will be there and single output will be there. So now if you just see here, 5 and 6 both I have written as an output, but I am telling there is only one output, right? Listen, you can take the output either from 5th or you can take the output from 6th. Okay, both are output pins only. Do not take the output from both the ends. Okay, no need to short this. Usually we will be taking the output from the 5th pin. Okay, we are not using the 6th pin. Okay, properly listen. We are not using the 6th pin. We are taking the output from the 5th pin. And what is this S0, S1, S2? This is nothing but the select lines S0, S1 and S2. Which pins? 9th pin, 10th pin and 11th pin. And the 16th pin should always be connected to the power supply, and the 8th pin should always be connected to the ground, that is 0. And 16th pin should always be connected to the 5 volts, that is a power supply. Whenever I am showing the implementation, at that time I will show where you have to give 5 volts, where you have to give 0 volts. See, in the experiment, the very important thing that what you have to understand is the design part. Implementation will just take a very few minutes in order to understand. The design part takes more time. Okay, the design, if you have understood the design, whichever the expression they are giving in the exam, you can solve and you can get the expression and you can realize it. I just show for one particular example, and the next example we will see in the next video. Okay, so now what I have written here, it is the same as you write for the truth table, right? See here, the 4 variables they have used in the question, that is A, B, C, D. So that's what I have written here, A, B, C, D, and I have also written the decimal equivalent in order to understand in a better way. Okay, A, B, C, D, and the decimal equivalent I have written, and I have just written from 0, 0, 0 to 1, 1, 1, 1. Okay, so now I have to write the function outputs. What is the function output they have given? So 0, 1, 2, 3, 9, 10, 15. So E combination atra. Okay, E combination atra, you are supposed to write 1. Okay, because it is a min term, right? It is not a max term. So if they have given a maximum, then that will be a different question. I will teach you on that also. So since they have represented the sum of min terms, the summation is there, the sum of min terms, you are supposed to highlight this combination with logic high, that is 1. So for the zeroth combination, okay, for the zeroth combination it should be 1. For the zeroth combination it should be 1. And for the first combination it should be 1. For the second combination 1. And for the third combination it should be 1. And for the fourth combination it should be 0, fifth 0, sixth 0, seventh 0, eighth 0, ninth it should be 1, 10th should be 1, okay, 11th 0, 12th 0, 13th 0, 14th also 0, 15th should be equal to 1. So now you all know how to write the MEV. You all know how to write the MEV. So what I was telling, so MEV technique or MEV output will be written for the two combinations. Okay, MEV technique should be written for two combinations. So let me erase this because I have to write the output for the two combinations, right? You have to map with the D. See here. So it is taking double 1, so I can write it as 1 here. Okay. Next, for these two combinations, again it is 2 ones, so very blindly you can write it as 1. Next, 2 zeros. For the next two combinations it is double 0, so just write it as 0. For the next two combinations it is 0, so you can write it as 0. Next, for the next two combinations, so it is 0 and 1, it is same as the D value, that is 0 and 1, so therefore I write it as D here. Okay, and for the next two combinations it is 1, 0, it is just the complementary of D, so therefore I write it as D bar. Why I am taking D? Because the variable D I am comparing this output with the variable D, so therefore I have to write it as D. You should not write A, B, C, you cannot use whatever the variables you want, you have to always map with this last variable. Next, for the last two combinations it is again both outputs are 0, just write it as 0. Next, for the last two combinations the output is 0, 1, it is same as D, so therefore write it as D. So now what I will do, I will just take this as D0, this as D1, this as D2, this as D3, this as D4, D5, D6 and D7. Okay, so now it is very easy for you to write down the circuit diagram. So that's what they are telling you. So using the 8 cross 1 you are supposed to realize the logic expression. So now you have got the outputs. You are supposed to, what are the outputs you have got? You have got 8 outputs. I mean the 8 combinations, for all these combinations you have got all these 8 outputs. So this 8 outputs will be given as an input to the 8 cross 1 marks. Very, very important. So whatever the outputs that you have got in the truth table, this is the MEV, MEV outputs. So these outputs will be acting as 8 inputs to the 8 cross 1 marks. So again I am considering this 8 cross 1 marks. Okay, this is the 8 cross 1 marks. The same thing, the pin configuration I have written there. So what is D1? Sorry, what is the first pin? It is D3. What is the D0 pin? It is a 4th pin. So what is your 4th pin should be connected to? See, D0 means 4th pin, right? D0 means here, D0 means 4th pin. D0, D1, D2, D3. So D0, D1, D2, D3. What I have to connect? D0 and D1. D0 and D1 is nothing but 1. So let me write it in that also. So this is a D0, this is D1, this is D2 and this is D3. Okay, and this is D4. Okay, this is D4, and this is D5, this is D6 and this is D7. Okay, these are the select lines, that is S2, no? Okay, S2, S1 and S0. Okay, and again the 5th is the output and we are not using the 6th pin. Okay, so now what is your D0? D0 is 1. D1 is also 1. So now I will short both this. Short means connecting a single wire for both the pins, and I have to give it for high. Let me write it as high. Because this is high now, it is high. I'll show you how to give high and all, how to give high, how to give low, all those things I'll show, but just understand how to write this circuit diagram. Okay, what about D2 and D3? D2 and D3 both are shorted and it should be connected to ground, that is 0. So that I will write it as low. This is high and this is low. 0 means low. Next, D4 is connected to what? D. D4 is connected to D. Okay, D4 is connected to D. What is D5? D5 is D bar. I just come to this point. D6 is what? 0. So D6, which is D6, this is low. This should be connected to low. And what is D7? D7 is also D. So therefore I short this D4 and D7 and I will give it for D. Okay. So this D4 and D7 are being shorted and it is given for D. So now you want D bar. How you will be getting D bar? How you will be getting D bar? If you are giving this particular input to one of the inverter or one of the NOT gate, you will be getting D bar. So you can use one of the NOT gate here. I think it is visible. You can use one of the NOT gate from here and you can provide it. This is nothing but the D bar. Okay? This is nothing but D bar. Whatever the output that you are getting from the NOT gate, that is called as a D bar. Okay? I'll just write down very neatly. Okay. Here you will be getting D bar. Okay? And what about this S0, S1 and S2? That is nothing but A, B and C select lines. This is A, B and C. These are the select lines and you are taking the output from the 5th pin. And the 6th pin we are not using and the 7th pin is called as a strobe. Even that is also we are not using. 7th pin is called as a strobe. We are not using the 6th pin and 7th pin and 8th pin we are connecting for ground and the 16th pin we are connecting for the power supply. Okay, let me explain how to connect this or how to write the circuit diagram. Okay, so D0, D1. So what I have done in the white chalk is that one we have just copied it from the configuration, that is the pin configuration. So if you just look into this table, so what is the D0, D1? D0, D1 is 1, 1. That is D1, D0 and D1 is high, logic high. I have to connect, I have to short these two pins and I have to connect it for high. And what is this D2, D3? Both are 0. I will short this and I will connect it for low. Next, what is D4 and D7? D4 and D7 is D. So therefore I am connecting D4 and D7 and shorting it and connecting it for D. Next, D6 is low. D6 I am connecting it for low. And D5 is D bar. You have to get D bar. How you will be getting the D bar? If you are just passing the D input to one of the NOT gate, you will be getting the D bar. And that output of the NOT gate is connected to the 14th pin. I hope you are clear with this. Okay, we'll solve some more problems, then you may understand in a better way. Okay, please take down this very neatly. This is one such experiment, and again, what you have to understand is this expression will not be common for the third experiment. Okay, they may give a different question. Okay, they may give a different question. Based on this question, your truth table will change. If the truth table gets changed, obviously your 8 cross 1 marks circuit diagram will also change. Okay, please take down it properly. Okay, we'll solve some more problems related to this and understand the concept in a better way.